Hello viewers, welcome to our YouTube channel Incredible Maths. In this video, we will solve a problem asked in CSIR NET September 2022 in the unit of linear algebra. The problem is, let R be the field of real numbers, let V be the vector space of real polynomials of degree at most 1. Consider the bilinear form is a function from V cross V to R given by f comma g, inner product of f comma g is equal to integral 0 to 1 f of x g of x dx. Which of the following is true? So we have four options. So from this we have to check which one is true. It's a part B question, so therefore only one option will be correct. So therefore we have to choose the single correct option. The first option is, for every non-zero real number a comma b, there exists a real number c such that the vectors ax plus b comma ax plus c, x plus c belongs to V are orthogonal to each other. So we know the condition to check orthogonality. So the condition for orthogonality is inner product of f comma g is equal to 0. So now we will work out the first option. We will check the first option is correct or not. So given that there exist two vectors, so the condition, so first we will write, so the condition for orthogonality of two functions or two vectors, so here two function is, so inner product of f comma g equal to 0. Here the two vectors are given as ax plus b, first vector, and the second vector is x plus c. So we will find the inner product for these two. So inner product is defined as integral 0 to 1 f of x into g of x dx. So this is f of x and this is g of x. So this one is our f of x and this one is g of x equal to 0. So now we will simplify this one and we will find c. So integrating this, so before that we will simplify this one. So elaborate ax plus b into x plus c. So the first term ax square plus acx plus bx plus bc times dx, integral is 0 to 1 equal to 0. So integrating we will get x square by 3, here x square by 2 and here x square by 2 and here x. So integrating x cube by 3 plus ac x square by 2 plus bx square by 2 plus bcx. So the limit is 0 to 1 equal to 0. So we will substitute the limits. So we will get a by 3 plus ac by 2 plus b by 2 plus bc. When we substitute our lower limit, so every time it will become 0. So therefore this is equal to 0. So from this we will try to find c. So you get ac by 2 plus bc equal to minus a by 3 minus b by 2. So we will take LCM both left hand side and right hand side. So we will get c times a plus 2b by 2 equals minus times 2a plus 3b divided by 6. So after simplification we will get c equal to, so minus times 2a plus 3b divided by a plus 2b. So now we will see the option once again. So option A says that for every non-zero real number ab, there exists a real number c such that these two functions are, these two vectors are orthogonal to each other. Okay. So now suppose if we choose, okay, if a equal to minus 1 and b is equal to 1 by 2, so you will get 0 in the denominator. So for this value of a and b, so there doesn't exist c such that these two functions are orthogonal to each other. Okay. Then a plus 2b becomes 0. So this implies there does not exist C such that ax plus b comma x plus c equal to 0. So implies A is wrong. So now we have checked the first option is wrong. Okay, so this is for A. Okay, so similarly we will check for option B. Option B we will work out here. Option B, so we will see the option B. For every real number B, there are infinitely many real numbers C such that the vectors are orthogonal to each other. So similarly we will find the inner product of these two vectors. So 0 to 1 x plus b times x plus c dx is equal to 0. So we will find C. X square plus cx plus bx plus bc into dx integral 0 to 1 equal to 0. So integrating and substituting the limits, so we get x cube by 3 plus c x square by 2 plus bx square by 2 plus bcx. So the limit is 0 to 1 to equal to 0. So you will get 1 by 3 plus c by 2 plus b by 2 plus bc equal to 0. So from this we will find c. So c is equal to simplify c times 1 by 2 plus b equal to minus 1 by 3 minus b by 2. Simplifying we will get c times 1 plus 2b by 2 equal to minus 2 minus 3b divided by 6. So we get c is equal to minus 2 minus 3b. So this we can cancel out, divided by 1 plus 2b. So the option says that for every real number b there are infinitely many real numbers c. Okay. Suppose if b equal to minus 1 by 2, so there doesn't exist c, such that this x plus b and x plus c are orthogonal to each other. So this implies option B is wrong. So next we will go for option C. For C, so the function given is for every positive real number C there exist infinitely many real numbers a comma b such that the vectors are ax plus b and x plus c are orthogonal to each other. So these functions, the orthogonality for these functions already we have find out in option A. Therefore we will take the result from option A. So what is C? C is minus times 2a plus 3b divided by a plus 2b. So the option is for every positive real number, C there exists infinitely many real numbers a and b. So here we will fix, suppose if we fix C as 1, then we will see what happens to this A and B. Suppose C is equal to 1, so left hand side will be 1, so we'll get minus 2A plus 3B divided by A plus 2B. So we will get A plus 2B equal to minus 2A minus 3B. So we will collect A on one side and B on another side. So left hand side will be 3A equal to minus 5B. Okay. So therefore, there exist infinitely many A and B satisfying this condition. So therefore, option C is correct. So implies there exists infinitely many A and B satisfying the condition. So therefore, option C is correct. So therefore, so we can end this problem. So this is wrong and this is wrong and this is correct. Since this is a part B question, so only one option will be correct. So anyway, we will check the option D. Okay, so what happens to option D? So here we will do for D. So what is D? Option D, for every non-zero real number. So this is non-zero. For every non-zero real numbers B, there are infinitely many real numbers C such that these two vectors B and X plus C are orthogonal to each other. So we will find the inner product of the inner product of the functions B and X plus C. So B times X plus C integral 0 to 1 dx equal to 0. So integrating, we will get bx square by 2 plus cx. So the limit is 0 to 1 equal to 0. So applying the limit, b by 2 plus c equal to 0. So therefore, so here we get bc. So given that for every non-zero real number, so therefore we can cancel this b, dividing by b on both sides, get this one. So this implies c is minus 1 by 2. So therefore, for every non-zero real number, so we get unique c. So this c is unique. So this c is unique. Therefore, there does not exist infinitely many real numbers. So this one, so this implies option D is wrong. So therefore, the only correct option is option C. Okay. If you like the content of this video, kindly like, share and subscribe. Thank you.